Okay, so we're gonna get started. Welcome everybody to the microbit webinar. We're gonna just introduce you to microbits, tell you a little bit about what they are. So if you've never seen one or used one, you'll learn today what they are. And we're gonna explore how they can be used, and I'm gonna demo how easy it is to use them. They're probably my absolute favorite physical computing device on the market right now. So a couple things: if you want a copy of the slides to this presentation, the bottom left corner of the PowerPoint has the shortened URL to open up these slides so you can have a copy for your records. And if you want to reach me on Twitter, @TeachMeCS is my Twitter handle. But again, the bottom left-hand corner is the URL to access this slide deck. So, and I'll go ahead and put that in the chat box because I think that some people may want to be able to access that in a moment. So let me get that in the chat box. For some reason, it's not showing up on my screen. Well, I can't put that in the chat box. I'll come back to that and I will put that for you guys in the chat box later. So again, the slides are in the bottom left-hand corner if you'd like to access the slides during the presentation, and I will put that link at the end as well. Okay, so what is the microbit? What is the microbit? The microbit is, like I said, my favorite physical computing device. I'll show it to you in a minute. I do have one with me here and I will hold it up on the screen in a second. But I like to do my little sales pitch first as to why this is a really great choice. So first and foremost, it's one of the easiest devices out there to connect. It's plugs in like a USB drive, and once it plugs in, that's the only real connection that has to happen to program it. So it is recognized on the computer as a USB drive, basically, so it like a flash drive, and you just drag files onto it just like you would a USB drive. So that makes it a very similar, easy format that students have, most of them have had that experience of moving files to a flash drive kind of thing. So there's not a lot of like installations or drivers or things like that, which makes it super easy, which is very, very exciting, especially for the middle school space and the elementary space. Also, the statistics from microbit directly is that 90% of students say that it helps show that anyone can learn to code. So it's just a very accessible format. And then of course it's very affordable. My favorite thing about it is it's $15, $16, $17, depending on which bundle you get. Some of them go up to about $25, but you can't get cheaper than that in the classroom environment. So let's take a look, a deeper dive, and I'm going to actually show you this device. We're going to look at it. I love Microbit's website, so we're going to take a departure from the slides for a little bit and go to the Microbit website to learn a little bit more about the microbit. To give you a little bit of history, the microbit is coming out of the UK. The BBC funded the development of the device and has since been working on getting the device to all of the schools and students in the UK, which I think is really, really awesome. And so the BBC, like I said, is the ones that developed this microbit platform, and it's a handheld programmable microcomputer. And to hold that up for you, it's about this big. So to give you some perspective, one moment, I'm working with two monitors here. To give you some perspective, here's my hand, okay? A normal pen. It's a pretty small device, okay? And this is what a microbit looks like. And the microbit is a microcomputer. It has a lot of features. We'll dig into those in a moment, but it can be used for a ton of different physical computing activities. And when I say physical computing, the idea with physical computing is being able to take a coding language or a programming language and bring it into a physical sense. Most physical computing devices have LEDs. I've already programmed this to do a little activity. We'll show that in a minute. They have LEDs, they have sensors, they have input and output. And so that's what physical computing can bring into the classroom, is this ability to see and feel and touch your code doing something. So you can actually see the code that you've programmed do something, which is one of the great, great benefits of physical computing. One great thing about the microbits in general is that they're extremely easy. So they can be programmed in a block-based programming language called Microsoft MakeCode, which we're going to look at today. They can also be programmed using JavaScript, Python, Scratch, etc. And with all of the different softwares, different languages, there's many of them don't require any software installation at all, which means they're Chromebook compatible. These are also Android and iOS compatible, so there's just a lot of versatility with the microbit. Another great thing about the microbit is it's like swept the world. I don't even want to say the nation because it's coming out of the UK. It swept the world. And so because it's taken off in the last about 2.5 years, I got my first microbit 2 years ago at the Summer Computer Science Teachers Association conference, and it was just coming over to the United States around that time. So it's only been in the United States for about 2 years. And since then, there's like hundreds and hundreds and hundreds of activities and ideas and examples and just exciting things you can do with your microbit. And they've also swept the school systems worldwide as well, because they're a very affordable and accessible platform. So many, many countries are using them. Finland and Iceland and Singapore and UK and just all over the place are investing in these devices. They've actually been on back order quite a bit. They constantly are going out of stock because of the such high demand in the last 2 years. They really are one of the best physical computing devices out there for introductory computer science. So some features. Let's talk about what this little tiny device can actually do. Okay. And if you're following along on the PowerPoint slides, the next slide is about the features of the microbit, which is where we're at. Okay. So the link is there, or you could just click through on the website. So the microbit has a lot of built-in features, which I love. So I'm going to try and point those out to you as we are also looking at the icon on the desktop here. I can also show you on the device itself where some of those are. So if you want to make my video screen bigger, you can. But basically, there's two sides of the microbit. And like I said, it's pretty small, and I'm actually going to unplug it here. Okay, there's two sides, and this side here is, I guess, what we would call the front. And the front has capacitive touch connectors on the bottom. Okay, and there's an LED matrix right here. There's two input buttons, which we'll learn, A and B buttons, and we'll see what those can do. And the USB connectors up here on the top, along with a battery connector and a reset button. Well, it's actually on the back. So the back of the microbit, like I said, has the battery connector, the reset button. There is a radio and Bluetooth antenna. So there's Bluetooth built in, but there's also radio built in. So microbits can actually communicate and talk to each other, which is really, really cool, because when you have multiple microbits in your classroom, you can assign projects where one group interacts with the other group. So they can send a message back and forth, or they can press a button on my microbit and it can control the microbit next to mine. And it's really simple to do, and it's really cool. The processor's right here. There's a compass built in, and I love that on the microbit, all of these things are labeled so your students can see how the circuit is built, but there's a compass, and the compass has an accelerometer as well. And so you can, your microbit can tell what direction it's being tilted, which is awesome. So there's quite a few features here built in to the microbit. Okay, that's pretty much what's there. And if we scroll down, we can learn a little bit more about some other features as well. So there's a light sensor and a temperature sensor built into the microbit. Like I said, the motion sensors are there, and then the radio and the Bluetooth. And so there are 25 LEDs that can be programmed individually as well as programmed as a whole. And if you're looking at the screen here, you have like a blinking heart icon, and we're gonna all get to program these. Even though you may not have a microbit in your classroom with you right now, you'll still get to program today, which is really exciting. And like I said, there's the A button and the B button, and you can detect whether one is pressed or both are pressed, or if it's being held down. So there's a lot of ways those can be used as input instead of just a tap on each one. The pins along the bottom allow you to connect additional components to your microbit. The most common for introductory programming is using alligator clips, which are usually they come in multiple colors, and they have a little metal clip on the end, and you can clip parts to them. And so that's what the pads along the bottom are for. They're also used for add-on devices, and we'll look at that later on, where you can snap your microbit into actual extensions and add-ons. There's a light sensor on your microbit, and the light sensor is actually very unique on the microbit, which is what's really cool. The LEDs themselves actually are the light sensor, which is really cool because typically there's a separate diode that's detecting light. And in this case, they designed it so that your LEDs are the light sensor, which then also keep in mind though means that if you have the LEDs on, you can't really detect the light. So there's a little downfall there, but it saves some space on the microbit. There's also a temperature, and the temperature on the temperature sensor on the microbit is going to detect the temperature of the device itself, not necessarily the temperature in the room. So like if the device is getting warm because it's on, or the LEDs have been lit on for a while, the device itself might get a little warmer or it's plugged in. You know how your cell phone kind of warms up sometimes. So the microbit can just keep that in mind, that it's not necessarily detecting the temperature of the space around it. It does detect the temperature of the device as it's right there. So the accelerometer has an X, Y, and Z reading, and we can look at that in a little bit, but you can detect whether it's been moved. But along with that, there's some pre-built-in sensors, like did you shake the microbit? Did you tilt the microbit? Or is the microbit dropping in a free fall? And so those are some built-in detections that are already programmed by microbit to determine how your microbit is moving. So you can do all sorts of projects using the accelerometer as well. There is a compass, which allows you to detect which direction your microbit is facing, just like a normal compass. And you do have to calibrate that. So that's not something we'll get to today, but that is a built-in feature of the microbit. As I said previously, there is a radio. There is a radio communication to allow wireless communication between microbits, which allows your microbits to talk to each other in the classroom. And then because they are Bluetooth, it means that we can use our phone, we can use our tablets as well to control microbits. And you can also, so you'll just pair your microbit. We're not going to do Bluetooth today just because it can be a little temperamental. And then of course, as I pointed out, there is a USB port, and it plugs directly into the device, a Chromebook or a Mac or a PC using the USB. So there are some features of the microbit as a general overview. So again, the slides, I will put the link real quick in the chat box for those of you who have just come in to the bit.ly site so that you can see the slides that we are working off of. So I'm going to type that real quick. I just want to make sure I have the right URL into the chat box. So those of you just joining us or joined us after that first slide was up, I will put the URL to the slides that we're working off of in the chat box so that you can follow along as well. And so that was the slide that went through the features of the microbit. And again, this is the size of it. Here's a pin for comparison. So you can kind of see how the size of a microbit is. Okay. So just based on the features of it, you can already start to see that there's a whole bunch of things that this could possibly do. If those features are like, I have no idea what a light sensor is, that's okay. Don't be overwhelmed. We're going to look at it. We're going to dig into some of the activities that can be done, and you'll see very quickly how easy the microbit is. It really truly is probably the easiest coding activity, like platform. Microsoft MakeCode's one of the easiest platforms out there, and the microbit is one of the easiest physical computing devices out there. So if we return to our slides and continue along, get back to full screen here. We left off on our microbit features. So let's take a look at how we can use the microbit, how we can actually program this thing, okay? So as I had said earlier, the microbit has a lot of versatility. So in terms of the device that you can use, it's very versatile. There's tons and tons and tons of devices it's compatible with, but there's also many different platforms that it's compatible with. And so with that comes with options for programming. So the number one option that most people use with the microbit when they're just starting out is Microsoft MakeCode. And that's what I'm gonna demo and you're gonna get to use today is Microsoft MakeCode. Then there's Scratch 3.0. So if you're not aware, I did a webinar on Scratch back in, I think, November. The recording was in the newsletter today, as well as posted on the Lowcountry CSTA website. But the new version of Scratch came out just after the holidays in January. And the new version of Scratch 3.0 is iPad compatible now, but also has a lot of capabilities for physical computing devices. And so I've attached the link here on this slide to connect a microbit to Scratch 3.0. You do have to install a driver. Well, you actually don't install the driver on the computer. You download it and install it on the microbit itself, but you'll download and install the code onto the microbit so the microbit can talk to your Scratch program on your browser. If you have Windows 10, there is an actual app in the App Store which allows you to control microbits in a Windows 10 environment, which adds a lot of features for data collection, which is really awesome because you can start to get into a lot of really high-level science data collection activities in Windows 10. And then there's the Android app and the iOS app for phones and tablets. And then if you have iOS devices, specifically an iPad, there is an iPad app, if you're not familiar with it, called Swift Playgrounds, which is an introductory app for learning the programming language Swift, which is used for making cell phone apps. So if you wanted to make an Apple app, you could use Swift, and Swift Playgrounds is the beginner introductory app for iPads that teach that language, and they now have capability to control microbits using the Swift language as well. There are other third-party companies, I've linked one at the very end, that you can also program the microbit in, like Python and MicroPython, and other platforms do have microbit compatibility. These are just the ones that are officially endorsed by Microbit Foundation here on this slide. And they're the ones that most people will use just getting started. So, like I said, Microbit does a really great job of documenting and providing very useful information. The great thing about the Microbit website is it can be a little overwhelming because there's so much, but all of it is exciting, useful stuff, and it's not weighed down with information that you might just find tedious to sift through. Everything on there is very easy to navigate, easy to find, easy to sift through. And so I do like to refer you back to the website just because I think the website does a really great job of making things easy to find. So if we go to the quick start guide, I can walk you through just how simple it really is to connect this, and then we're all gonna get into the programming software, and we're gonna program a microbit. And again, you do not have to have a microbit to program one today, which is what I also love. But I did want to just show you the steps that I'm going to take to connect my microbit to my computer. So it's as simple as plugging in your microbit to your through a USB cable to your computer. And when you purchase your microbit, you get mine came officially from Microbit, so it comes in this box. If you buy one from like SparkFun repackages it into a SparkFun box. If you buy from Furia Labs, they also give you a classroom pack, and it comes in like one big box for the entire classroom pack. Sometimes they come bubble wrapped, but this is the official retail packaging. So if you buy it from Amazon, from the microbit as the manufacturer, you should get a retail box like this. This is the Go Kit, and the Go Kit comes with a battery pack. So when you get the microbit, it does come with like a small little battery pack and it comes with AAA batteries and a very small, very short micro USB cable, okay, which I'm not using today because I would not be able to hold my device up to my camera with that very small cord. And so there are also other accessories, like you can get, like this is a little case that someone purchased for me as a gift, but it's like a little kitten case that goes on it. So there are different cases and things like that available. Like I said, the microbit has taken over in terms of introductory physical computing devices, and there's so many different manufactured accessories now for it. So I'm using a much longer cable, but basically you just plug it in and you're connected, and there's a default there's a different thing that says hello world when you first plug it in, that shows you it's connected. In this case, I've already reprogrammed it a bunch of times, so the default one's not there. But then you just begin to program it. And like I said, the quick start guide does recommend the make code editor. And step 3 will be to just download your code. And like I said, when you plug in your microbit, it shows up on your computer as a USB drive. So if you're familiar with Mac, you are, you know that a USB drive, when it's connected, will show up over on the left-hand side under devices. And so like my microbit is showing right here as microbit, and it just shows up as a USB drive attached to my computer. And when you're on a PC, it's going to be very similar. It's going to show up on a PC as like a USB flash drive. So in this example on this screen, it shows when it's plugged in as a microbit D drive. So whatever your next letter to map a drive is. And then once you drag and drop the files, it's there and it'll automatically play. And it will eject the flash drive automatically as well. So it'll just go ahead and eject the drive, so you don't have to worry about like unplugging it and causing any corruption to the microbit or anything like that, because it automatically ejects it both on the PC and the Mac platform. So that's just a quick overview. I'm going to demonstrate that in the actual environment. So we'll we'll walk through these steps in great detail here in a minute. So before we jump into seeing example projects, example code, and coding our own, do we have any questions about basic understanding of what the microbit is and what it looks like and what features it has? We'll get some ideas here in a minute of how it can be used. So I'm getting to that still. If you have any questions, feel free to raise your hand or unmute yourself and ask, or post them in the chat box. I just want to make sure that we kind of have a good understanding of what a microbit is and what it may or may not be capable of. Okay, well, let's continue on then. We're going to begin programming our microbit, and this is where you get to join in. That's not there. I do have it open, I thought. Okay, so on your computer, feel free to find a web browser and navigate to makecode.microbit.org. I will also put this in the chat box. It's also in the PowerPoint slides. No, it's not. It's on the Quick Start Guide. Makecode.microbit.org. Very simple URL there, makecode.microbit.org. And you will get to see the coding environment. And everyone can code today, even if you do not have a microbit. Just making sure that everyone realizes they can do some hands-on activity today. So what I love about all of the MakeCode platform. If you're not familiar with MakeCode, Microbit is not the only device that programs in MakeCode. The Adafruit Circuit Playgrounds, which are also Code.org's official physical computing device, the Circuit Playgrounds also program in a MakeCode version. The Chibitronics Love to Code Chibitronics block programs in MakeCode. MakeCode also has a Minecraft extension, and there's a few others now that have, I believe, the Lego WeDo programs in MakeCode now as well, but there's a few others. MakeCode is gaining in its popularity for programming physical computing, and it's also the language that is used for the Minecraft Education Edition coding. But anytime you open up a MakeCode website, in this case, the Microbit one, there are lots of examples and tutorials here. I mean, you could spend hours exploring all of these examples, and these examples have starter code for you that you can start with and then modify. Some of them are actual step-by-step tutorials with the code as well, and some are just example projects. But there's all sorts of projects here. We'll come back and explore these in a little bit. I want to go ahead and do our first activity or our first project before we take a moment to look at everything it's capable of. So if you click the purple icon here, New Project, it will take us into the coding environment. Might take a moment, especially if it's your first time loading it. Okay. Mine is still loading, so give it a second. So I want to introduce you to the basic interface here so we can understand what we're looking at and get familiar with all the different features and how the interface works, how to save and all that good stuff. So let's go through what we're seeing here as our interface. So across the top, you have a navigation bar, and I'm actually going to go into full screen here, gain some real estate. I'm on a tiny little screen. Okay, so across the top is a navigation bar, and that navigation bar has the home, which will take you back to that screen we were just at. It has a share, so you can actually get a URL to share this project out. So if you were making a project or a lesson plan and you wanted to share it with your students, you could do that there. You have a toggle switch here that will switch from blocks to JavaScript code. So if I click on that in a moment, you'll see that we have switched to JavaScript. Okay, and you can go back to block as well. So that's what's really neat about the MakeCode environment. It's a very easy swap between the block-based programming and the JavaScript programming. And a lot of teachers who use microbits in the classroom say that their students actually begin to prefer the JavaScript mode without it even being an intentional part of the lesson. So without the teacher saying you have to use JavaScript mode, they find a lot of their students as they begin to use the program more and more and code more and more in MakeCode, that they find that JavaScript is faster and they start to really rely on it. And so it's just a very organic way of learning a text-based language for these students. There's also question mark, which has a phenomenal help section, and then there's some settings. We're not going to get into any of that today, but those are there as well. We have our emulator in the top left corner. So like I said, you don't have to have a microbit to do this because you will get to see your code run on this emulator. And this emulator is great because it allows your students to see their code working on the virtual environment before they actually take the time to download and put it on their microbit and see it in the physical environment. So when we are in MakeCode, we have our coding categories here, and we can see that there's different categories of blocks. And when you click on them, some of them have more options, but each category is color-coded. If you're familiar with any block-based programming language, most of them are color-coded. And so the colors each block of code that's in a certain category will stick with that color. So it makes it easy to read tutorials and follow tutorials because it gives that added visual element of it being color coded. Okay. And then we have our, the coding, the space on our screen where we can put our actual code. So this is currently, we have two, like on, start, and forever. They're just basic control blocks, and they're currently empty, so nothing's really going to happen, but they give those as a starter project. And if you hover over them, they tell you what that code does. So on start will run the code when the program starts. So it runs once and the program starts. And the forever block repeats the code forever in the background on each iteration, and it allows other codes to run. So it's just running forever in the background as the microbit is on. And that is actually what I have going on here. I put this heart smiley face program into the forever block just to test my connection earlier, and it's just repeating forever. And it just will keep going as long as there's power to my microbit. Okay. So we're going to practice our first code, our first project here, and then we'll learn about this bottom bar along the way. The bottom right-hand corner has an undo and redo and a zoom in and zoom out. So you can make your code bigger and smaller down here if you need to see things bigger on your end. You can also just click and drag on the coding canvas to move it around if necessary to position things all together. Okay. So we're going to do a basic light up. So you can go to the basic and we'll look at some of these blocks that are our options here. And so there are some predefined things here like show number. And if I were to put show number and I put 10 here and then play in my emulator, it scrolls through 10. So there's like a pre-built in one there. But what we're going to do is we're going to choose show LEDs. And we're going to put it in the forever. So all I'm doing is finding a block and dragging it into my canvas, and notice that they kind of snap into place like Legos. If I put it where it's not connected to something, it's going to be grayed out, meaning that code is not connected, it's not going to run. Or if I snap it in the right spot, it won't be grayed out, it'll stay blue because that means it's able to run where I've put it. Okay, and that's, if I wanted to delete something, I drag it right back into the menu over here and let go. You'll see a trash can appears there. So I can attempt to draw a heart. So, you know, you can just click and drag in here and draw a shape and it will show up. If you want to uncheck one, you click on it again and it'll uncheck. That's how we can draw pictures. So we can do all sorts of different pictures or icons here. And then you should see in your emulator on the left-hand side, a heart. To navigate our emulator, down along the bottom underneath it, there's a run button, which is a stop sign if it's already running, or it's a green triangle start button if it's not. So there's a start and stop. There is a restart. So if I don't actually want to start and stop and I just want to restart it, I can hit the restart button and it does both of those in one. I can also slow it down. And if you use the snail or slow-mo or slow motion button, what will happen is it'll go step by step so you can see things. Because sometimes when you program your physical computing device, it'll go really, 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 really fast. And you want to be able to see where your mistake may be or how it's processing the code. So you'll want to do it in slow motion. You can also turn on and off your microbit. So your microbit does have a buzzer, like a little buzzer sound in it. And so you can turn off the sound if you don't want your microbit to make noise. Okay, so you should see a heart there. To name this file, so right now it's automatically saved untitled, and so if you were on your home screen and make code, it would say untitled. So down along the bottom is where we change that. And I'm just going to call this heart LEDs. Heart LEDs here. Now, I did get a message from someone in the chat that their school district has blocked the emulator. That would be a district level problem, and I would encourage you to reach out to your district to have it unblocked. I know in our school district we have to get things unblocked often that are educationally appropriate, and this one is from Microsoft, and typically in my district, since it's made by Microsoft and it's made by a legitimate organization, we wouldn't have issues in our school district getting it unblocked. So if I type in the name down here and hit the save icon, it will go ahead and save my code for me. And now my project is saved. I haven't downloaded it. I haven't uploaded it to my microbit yet, but it is saved. So if you wanted to save your project so you have it to look at later, that's how you would do that. And then, so how do I get that code onto my microbit? So the way that works is you would hit the download button. So if you have a microbit, you can do this. If not, you can just watch this part. When I hit the download button, it's actually going to download my code, and here it is downloaded. And if you download it before you name it, it's going to come downloaded as an untitled file, which is really not the best. So you want to encourage your students to name their file, then download. So I've downloaded it, and MakeCode's really nice. It tells me the steps to do it, to put it onto my device. And it also says that if it wasn't downloaded, I can hit this green download button and download it again. But basically, I need to connect via USB, which I've already done. And then I need to move the .hex file that was just downloaded and drag it to my microbit drive. So if I go to my Finder on a Mac, or if you're on a PC, you can do this on your PC. But I should be able to go to the downloads folder, and the heart LED, actually downloaded it twice, is right here. And I can drag it to my microbit. And I'm going to show this on the screen so you can see it. And when I drag it to the microbit, it's going to download and install. My microbit went blank. There's a light on the back blinking, and the light on the back is telling me that something is downloading to it. And once it's done, the light goes solid, which tells me it's running something. And if I turn it around, there's my heart. I'm going to flip it over for you. So now that code is forever going to have a heart, because that is what my code said to do, forever have a heart. We go back to microbit. My code worked. And if you can see up here in the top right corner, I think you can see it, it says disk not ejected properly. That's because when you download the code, it automatically ejects the flash drive off. So you'll see if I go back to my Finder on the PC, my microbit drive is no longer there. And it's no longer there because my microbit it automatically ejected itself. And okay, so what if I want to start doing some more complex things? So that's the tutorials on the MakeCode website walk you through making a ton of different basic projects that don't require anything attached, any add-ons or anything like that. But it does really walk you through lots and lots of really cool things. I am attempting, I think being in full screen has kind of made this wonky. Give me 1 second. Let me get out of full screen here. Okay, so that was my heart LED project. I also made another project earlier that was called Flashing Heart, and that was the one that went from heart to smiley face. And I want to show you the difference there and what code I used to make that go back and forth. So, well, for some reason, the code disappeared. So I will put it back in here. So I used a show icon. Because that's way quicker than drawing the heart. There's some pre-made icons already here. And then there is a pause, which has it wait and it's in milliseconds, so I'm going to do 500 milliseconds. Then I'm going to duplicate by right-clicking, so I don't have to go find it again. And I chose the smiley face, which is right here. And then I can duplicate that pause again, so I don't have to go find it. And you just can right-click to duplicate that. This right here, if I run it in my simulator, you'll see the heart, smile, smile, etc. So again, to reiterate, the difference between on, start, and forever is if I want something to start one time. So let's say on start, I want it to say hello. So before it does anything at all, like before it does all this heart, smile, I want it to say hello. So if I run in the emulator, it's going to say hello. And then it's going to go into that forever loop and loop that forever. Heart, smile, heart, smile, heart, smile. Any questions on the basics of MakeCode? Because I do want to show you how some of the sensors and the accelerometer work while we're here. And then I'll show you some examples and then we'll conclude the webinar. Any questions about the basics of MakeCode? So I want to show you a basic example of how buttons work. So if you want to join in on this, you can hit the home button. We're going to go to a new project again, just because I like to separate out each of the skills that we're learning into a separate project. Makes it easier to go back and reference. And we're just going to call this button LEDs. Okay, button LEDs. So in this case, what I want to do is I want to press the A button and I want something to happen, something to show up on the screen. And then when I press the B button, I want something to show up on the screen. So instead of using the on, start, or the forever, I'm going to use an input block, So when I have on button A pressed, then let's do a heart icon. I'm going to wait 1 second. And then I'm going to turn off the LEDs. Okay, I'm going to turn off the LEDs, show LEDs none after that. So they'll all go off. Okay. I'm going to do this something very similar. So when button B is pressed, I want to show the smiley face and then turn off. So I can test this in the emulator before I take time to download it onto my microbit, and you can actually click the A button. So when you click the A button in the emulator, it should work. But it's not, so let's try downloading it and see what I did wrong. FYI, I have not tested this code. We're going in here blindly, so we might have to do some troubleshooting. Let me get my finder. So again, I am going to my downloads folder, taking that, dragging it to my microbit. It's currently downloading. I know that because the LED on the back is blinking, and it's ejected off my computer, so I know it's done, and the LED has stopped blinking on the back. So let's see if my code works here. Yeah, okay, I don't know why the emulator is not working, but if I press the A button, the heart shows for a second and then goes away. If I press B, smiley face shows for 1 second and goes away. I didn't think there was anything wrong with my code. My emulator might be having a little bit of problems on my computer, but I've done it before, so I'm not sure why it's not working today. But basic input using the buttons. And then if you didn't notice, I can actually program when the A and the B buttons are pressed. So there was something here that said A and B. So it can also know when you're pressing both buttons at the same time instead of just one. Make sense? So I could program that to be something different as well. I'm not going to, but I could. So what other input did we say this device has? Who wants to kind of volunteer and answer to that question? What other input, what other ways can we give information? When I say input, I mean we're going to provide information to the microbit. So when we press the button A, that's input. It's similar to like the keyboard on your computer. We're putting information or data into the computer. So with the microbit, there's ways we can put information into the data, into the microbit. Does anybody remember some of the other features that the microbit has that will allow us to provide information to the microbit? Anybody want to unmute themselves or put in the chat box? Okay, we have the motion sensor, the accelerometer. That's a great answer. So how would I program the accelerometer? And we'll program the light sensor. Those are both really great examples. So let's do that. So we have an accelerometer. And so when we have input, there's some things we can do here. So we have on shake, that uses the accelerometer. And when we choose the drop down for on shake, there's when the logo is facing up, when the logo is facing down, that's using the compass. And then when the screen is up or the screen is down, or when we tilt it left or we tilt it right, or when it's free falling, or you have force. So when it has 3 G's of force, 6 G's of force, or 8 G's of force, like when it collides with something, which are all different ways that we can use the accelerometer to input into our device. So I can say on shake, okay? I can say on shake, and on shake, I'm gonna play a tone. I'm gonna play a melody so that you can kind of hear how the sound works. And I'm gonna zoom out on my code just a little bit here because I am on a small screen, okay? So on shake, and I'm going to play a melody. Oh, I lied. That one needs a speaker. I knew that. Somebody correct me. The microbit actually doesn't have a built-in speaker. Only, I think it does. Let me test that. I'm thinking of the Circuit Playground. Circuit Playground does. The microbit, that's right, does not have a built-in speaker. I apologize. We can't make noise without a speaker. But we can do LEDs. So that's what we're gonna do. The Circuit Playground from Adafruit does have a built-in speaker. That's what I'm more familiar with. We use those more. So if you shake it, we're gonna get a frowny face. How about that? We're gonna get a frowny face if we shake our microbit. And then we'll just have that show for a second, and then we'll have it turn on. So notice now on my emulator, there's now a shake button up here. So I can press the shake button and it'll emulate that shaking. And I am not sure why my emulator is not working. I'm gonna refresh this page for a moment because it typically works. Let me save it first. Okay, so let me start the screen over real quick. See if we can get that emulator to actually let us shake it. See what happens. There we go. Ah, it's moving now a little bit. Okay, there we go. So now if I shake, I get a frowny face. My emulator is now working. The A button gives a heart. The B button gives a smiley face. And when I shake it, it gets mad at me and gives me a frowny face. So that's a way we can bring that shaking in as an input. And like I said, there's way more than shake. There's what direction is it facing? Is the logo up? Is the logo down? The screen up, screen down, etc. Is it tilting? Those are also ways we can use that input. Somebody said the light sensor. So I do want to talk real quick about the pins. So the pins along the bottom, as a reminder, are there. There's more than these big ones. These little tiny gold lines are each actually a pin. They're just not programmed to be used for touching them. But you can hold down 0, 1, and 2. You can hold those down and they will actually become buttons as well. And so that's what's happening here. So on pin 0 pressed is going to be very similar as if I press the A button. So on pin 0 pressed, so if I hold it, it will know it's pressed. When you attach something with an alligator clip, you're basically saying whatever you've attached with the alligator clip, if data is coming in through that pen, it would be considered pressed. But you have this light level here. And notice the shape of this is much different. The shape of the light level is not something we can plug a block into. That is because this is a number. The number coming from the microbit is called a light level. This is a number. And so we have to tell the microbit what to do with that number, okay? And so what we can do is we can program our LEDs, because in this case we're really only working with the LEDs, to sorry, my tutorial off to the side just crashed. I don't know why that website's not opening anymore. So we can program the microbit to pull up or to react to whatever the light level is. So what we're going to do is we're going to program our microbit to, instead of pressing A and it giving a heart, we're going to press A and it's going to give us the light level. It's going to read to us the light level, which is really cool and really simple to do. So instead, I can get my editor to move here. There we go. Okay, so instead of these inside of press button A, I'm going to move all that out because I don't need that anymore. Delete that code that's in there. Okay, and so when A is pressed, we're going to go to Basic and choose Show Number, and we're going to choose Light Level. Now, those of you on the emulator, you should see on your emulator a light level up here. So when you press A, your light level is currently at 128. If you move it and press A, you'll see the light level here. So you get to emulate or put in a number for the light level right up here in the top left corner. But I'm going to download this onto my microbit so you can see the light level of my room, and I'm going to put it underneath the light and I'm going to put it in the shade and you can see the difference. Okay, so I'm going to just drag that to my microbit. Again, you'll see the blinking light on the back saying it's downloading. When it's done downloading and copying onto it, it will eject it. You'll hear that noise. There it goes. And it's done. And when I shake it, I know my code works because when I shake it, I get a frowny face, okay? Because that's one of the things we had programmed on there when I shake it. We also had it programmed on there when I press B, I get a smiley face. And when I press A, I should get a light level, which I'm reading in a mirror image. So I think that says 255, I think it did. Okay, so I'm gonna kind of make it dark, press the light level, and now I have 0 because it was too dark. Okay, so what if I kind of do, I'm gonna go a little bit of a distance away and get the light level. So now the light level is at 28 when I'm a little bit above it. So you can kind of see that difference there. The light level's at a 5. So you can control kind of and see the light level. Again, if I'm really close to the lights of my screen, I get a little bit of a higher number. What is that? 1? I didn't see that. Hold on. Made it mad. I'm reading in reverse. Was that an 18? So that's how you can read the light level off of your microbit. Again, I was trying to read that in a mirror image. I'm not sure if you're seeing it on a mirror image as well or just me. So the purpose of pulling you into MakeCode today was really just for you to see the simplicity of it. We don't have time to go into any more features or anything more advanced with the microbits in terms of actual programming. I did want to show you 2 websites on the microbit site, which is the ideas page and the teach page, because both are super awesome and sometimes a little overwhelming, but really, really cool. The ideas page has not only project ideas and lesson and like activities, but also like testimonials of how they're being used. It has video projects. It has links to people who are using them or who've written articles about them. Pretty much anything interesting to do with microbits is on this page, and it's really inspiring and really neat. And they do categorize them by like lessons and projects and videos, testimonials, etc., blog articles. It's a really, really great feature of this website. You should check it out. There's also the Teach page, which is specifically for educators. And again, it links to tons and tons of curriculum and resources. There's books out there now. There's tons of YouTube videos. There's so much curriculum out there that there's a lot of science curriculum where you can plug in like temperature sensors and moisture sensors and pull data off of the microbit. So there's some really cool science experiments as well. PLTW has integrated the microbit. There's just tons and tons of stuff out there. So the Teach page is also a great resource. My other favorite place for getting inspiration on how to use the microbit is Twitter. The Twitterverse is all over microbits. I mean, the microbit hashtag is probably one of my favorite ones on Twitter. The Microbit Education Foundation website is microbit.edu. Twitter handle is also a great one to follow. But like, if you just go to hashtag microbit, look at the videos or the photos, that's what I usually tend to jump to. You will see tons of examples. People are making Fitbits, people are making hot potato games, people are making like tug of war, people are making like text message where you can send a message from your microbit to another microbit. So there's all sorts of games, there's tons and tons of things. There's also add-ons to make your microbit into like a little robot with wheels, and like this one has wheels and a camera added to it. There's all sorts of really cool inspiration on Twitter. I encourage you to look up Twitter. So I'll come back to that question in the chat box in a second. So I wanted to take you back to the PowerPoint slides. Slide 7 is those links I just went to. Slide 8, also some of those links, the Twitter links, as well as SparkFun also has a guide to the microbit. So I wanted to make sure I included that for you because it's very comprehensive. A go-to question I always get is, where do I buy this thing? Here are some choices. They all take, I've personally ordered, well, personally, we as a school district have ordered from all 3 of these vendors in South Carolina. They all take purchase order. The top 2 are easier to order from than the bottom one. The bottom one has their own process that you have to follow. And where do you go with microbits once you learn the basics? Number 1, there's tons and tons and tons of interdisciplinary lessons. They are a great resource to bring into a science classroom to work with your academic teachers on bringing lessons in to teach some of their academic content. There is a company called Furia Labs. I have personally not used their product. It's loading, give it a second. I personally have not used their product, but I have met them and I have seen their product in action, and I'm already a huge fan of it. I would like to get more involved with it, but they sell microbits, and along with if you buy microbits from them, you get access to a Python-based programming environment, which is a text-based coding using Python, which is really cool. So that's like the next level if you don't want to use MakeCode. There's also tons and tons of add-ons, and some of those, both Studica and SparkFun and the Hummingbird, I can spell, the Hummingbird robot bit also is very good. All of those add-ons, the Hummingbird robot bit is basically turns your microbit into a Hummingbird robot. If you're familiar with those, they use they have vibration motors and servo motors, and they have tons of LEDs, tricolor LEDs. They have sensors. They have a light sensor, a distance sensor, a temperature sensor, all sorts of stuff. And the Hummingbird robot kit bit adds all that capability right to the microbit. So that's a great one that's out there. And like I said, SparkFun has a ton. There's a climate bit. There's a gaming arcade bit. There's the robot bit that gives it wheels. They also sell class packs and cases and battery packs and all that kind of stuff. But like, here's the one that turns it into a robot. Here's the one that turns it into an arcade game. There's all sorts of add-ons. This one allows you to attach all sorts of motors to it. The climate one turns it into like a climate station. There's the weather bit. There's just so many different things that you can plug your microbit into that gives your microbit much more capability, like a lot more capabilities. Studica also has a lot of microbits, and they have some vendors coming out of the UK, so some of the stuff they sell aren't as easy to find in the US, so it's nice because they bring some of that to you. But there are all these, like a sensor bit, and there's the sonar bit for the distance. There's the joystick bit, this battery pack bit to use coin cell batteries, a power supply. I mean, all sorts of really cool stuff for the microbit as well, through Studica, and it's like a never-ending list. So keep that in mind, that there's expansions that you can add on to your microbit to just give it more functionality, more projects, more things to do. So the question was, does this interface with the MBOT? The MBOT does not currently interface with the microbit. The reality is the MBOT is significantly more capable than the microbit. And so I'm not sure what type of functionality you would be able to have putting the two together, just because the MBOT has a lot of the similar sensors already in it. So not currently, no, it does not use MBlox software either. They really are separate platforms, but both of which program in you can program using Scratch for the microbit, which would be very similar to programming the MBOTs in MBlock. So that's something to keep in mind as well, is that the block-based languages for both the MBOT platform and the microbit are very, very similar. That is your brief introduction. I went 3 minutes over, but I did start 3 minutes late. So I think we're right on time. But that's your brief introduction to microbits. I do want to hang around if you have questions, if you want to share your experience. I know some of you on this call actually have experience with microbits and you've used them before. Like I said, I barely brushed the surface on what they're capable of. Go search Twitter and the ideas page to see how other people are using them. For the price point, you cannot beat the longevity these can have in the classroom. I mean, they're one of the cheapest things you can buy, and they are one of the most versatile things you can buy for your classroom. So they really are about less than 20 bucks. You can buy them on Amazon for $15, $16, $17. So absolutely well worth the money. I do want to make one more plug. If you like the microbit, but you think you're going to want some extra capability, I'm also a huge fan of the Circuit Playground coming out of Adafruit. It's at about a $25 to $30 price point. It has some extra capabilities that the microbit does not have. Specifically, it has integrated audio, a buzzer involved, and a few other things. So any questions, feel free to chime in. I'm going to hang around. I'll put back to the home slide. So if you came in late and you did not get the shortened URL for the slides, you can pull that up. The recording of this webinar will be posted on the Lowcountry CSTA website, as well as included in the next newsletter that will be hopefully going out next week. I'm waiting for the State Department of Education to publish a memo this week before I send our next Lowcountry CSTA newsletter, because there's some information that the State Department is finalizing regarding professional development and some legislative stuff that I want to share out in that newsletter. So again, if you have any questions, please don't hesitate to ask.
Not a question, just a thought. Usually I go into programming, like into Scratch, and then do the physical stuff later. I can see using these before I even go into the more complicated environment of Scratch, because they're so inspirational.
They are a blast and a lot of fun.
Yeah.
And they're also a really good, I only have 2 days. I only have 2 days and I want to do something fun with my kids. They don't have to be a 3-week unit. They're a great filler for a day where, half the class is at a pep rally.
Right.
You know what I mean? Like a certain 11th graders are at a pep rally and the rest aren't. You know what I mean? Like you only have part of your class, because they're so engaging that even if you don't even grade the activity that they're doing with them, they're just having fun. They're great filler for that. They're actually even they can be great sub-plans too. If you already used them once in your classroom and you have mature enough students to be able to handle that, they'd be a great sub-plan activity too.
Well, and I'm just thinking, you know, it's got a limited amount of blocks. I know it can really expand, but it seems like this would be easy for somebody not to get overwhelmed with the concept of programming and yet get some quick feedback because of the physical response. So, yeah, thank you.
I agree completely. And they're also really great, like if you wanted to have your students go guest teach at like a middle school class, or like partner up with an elementary school class and you take your class over, these would be a great one-day activity to take to that kind of environment too.
Okay. All right. Thank you.
You know me and ideas. I got to keep throwing them out because they come to me.
No, I didn't know if that was a hint.
No, that wasn't a hint. No. For those of you on the call and don't know it, Esther, who's speaking, works at my school, so I'm not hinting that she needs to do that. But the idea came to mind to present it to other people as well in case it's something they're.
No, well, I am inspired, so cool.
Any other questions that I can answer, or comments, or things you want to share out to the group? We do have a few people that haven't left yet that are still hanging around to hear what's talked about. Well, if that's a no from everyone, I'm going to go ahead and stop this recording and close out this call. If you need anything, don't hesitate to email if you have questions that you think of afterwards. And yeah, I hope you enjoy microbits. They're lots of fun.